Hello and welcome again. So we have almost completed the implementation of linked list. So I have added two more function, find and get frequency of. So find function I have declared in the header section. So find function is a boolean function and it will returns true if this function finds the node having this data, otherwise it will return false. And get frequency of function will return number of times this entry found in the list. So this function will return the number of occurrence of an element in the list. So let's see their implementation. So very simple. So boolean function, and we have just a while loop. In the beginning we have created one current ptr and assigned the head pointer. So um, then while not found and current ptr not equal to null pointer will be actually will be the last pointer. At the last pointer it will current pointer will be the null pointer after the last node. So then just it compares. So it will compare the data in the current pointer. If this data found, then found will be equal to true, otherwise we will move next, and at the end return found is returned back. So similarly this get frequency of a function is very simple. We can in the beginning we have frequency 0 occurrence, 0 time occurrence. Then we create current pointer and assign the head pointer. Then we have while loop. If data found, then we just uh, add 1 to the frequency, otherwise we will move. So these two functions are very simple. So let's see now. uh, this was our linked list implementation. So I'm duplicating it. So you can see then linked queue will be very simple. So we can have a linked queue here, linked queue. So we will just replace the linked list with the link queue, and we, as you know, we can add and delete elements from the front and rear end. So just we need to remove a few functions. So um, remove at back we do not need, so I am just removing this function, and remove at front I will just uh, name it dq, and remove at position we do not need this, because in queue data structure we do not do this kind of things. And insert, so we do not need. And insert at back, so this is something nq. So we will just change the name, and we can remove this one, and we can also remove the other. So just uh, we can modify a little. So just we can change like this one. We can have get set, get pointer to, get position. So we can use all these functions, get size, get frequency of. So this now become the um, queue data structure. So that means its implementation is very simple now. So let's see. So we will make a header file, linked queue, linked queue. So then we have here if defined, if not defined, if not defined, linked queue underscore h, then define linked queue underscore h, and the last directive is end if. So then we will have okay, uh, actually okay, let's copy all, and let's copy all. So let's see, I have copied the linked list implementation. So then uh, I can modify uh, I can modify things, but before I can remove. Let's see, um, this function I will remove function, remove add function, we do not need. So then remove add back, we do not need. So this is something nq, nq. It is something that we can just remove from the front. So uh, insert, this function we do not need. So insert at back, we need this one. At front we cannot insert. So this is something sorry, this is something dq, and this is nq. So we have these two functions. So rest of things we will see and modify. Let me uh, remove these functions, remove at. So we will and remove function, both will be deleted. And this is something remove at back, also deleted. So we do not need remove at front. So we will have nq. So remove dq, sorry, again I have the same mistake, dq. That means we are just um, and here insert at, we do not need. So insert at back, this we need. So we will just change its name nq. Rest of things are fine. And this function we do not need. So rest our functions are okay. So now let's change find and replace. So linked list, we want to replace it with the linked queue. So replace linked queue, linked list, linked queue. We are going to change all. Okay, we want to change change. Okay, change change. Yes, we want change 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 replace no more linked queue. So all linked list are replaced, and this is something also linked list and linked queue. Okay, so here we can also queue, and we can put here queue. So in the queue, so you can make a few more modifications. So let's see if there is any error, then you can just handle that error. So um, if you look at this dq function uh, and the nq function, you will see that we do not need get node at these kind of functions, get position, get pointer too, but these are still you can use in other functions. So I think you can remove it if they are not being used in any other uh, yeah, let me see. So we do not need, right? Find again we do not need, get frequency we do not need. Okay, then it is very simple now. Get size and get pointer to, you can remove it. Get pointer to, you can remove it. Get position, if you do not want to use, you can remove it. And get node at, you can remove it. So it means we can remove get position, get pointer. So these three functions we just remove these three functions. So then uh, the implementation become very simple. So uh, let's test it. So we can create here linked queue test, another function. So maybe I can make little bit one. Linked queue test, and we may have here body, and we need to include linked queue. And linked queue, we have created one object, and see out, we have printed this object. So let's see. We are not calling yet this one. Okay, no, what is list here? It is one error, undeclared. Okay, here we have here now queue size. Okay, so we have queue with zero um, zero elements. So let's add few element. Enqueue dot enqueue, and you can provide. So then we can have few more. So 2, 3, 4, and then we can print, and then we can dequeue. So delete, dequeue, and then again print. So we can then see. So you can see in the beginning queue was empty, there was zero element, then 15, 25, 35, 45 were added, and then the first one 15 was removed from the queue. So very easy. So similarly we can modify the linked list for um, stack data structure. So let's see here, header file, add new element, header file for linked stack. So add. So then again I will copy linked list. See, control V. So let's remove let's say so we can remove at front and also delete the insert at front. So this insert at front, we can name it push, and remove at front, we can name it pop, and then we can remove these two functions, and also we can remove these three functions. and let's modify insert at back, insert at front. So this is something push, and we will remove this one, so these two functions are removed, and the remove at front will be pop, and then we can remove, we can delete all these three functions. So um, these functions are also not using any these kind of functions, so we can remove them easily. Get node add, we can remove it. Get position, we can remove it. So get pointer to, we can remove it. Rest of get size and clear and is empty, these are fine. So let me these three functions we will remove. So our so if you want, you can um, just remove the last pointer, but you do not need, and you can change the name head pointer to top, but it's okay, you can um, you can use the same variables. So now let's uh, replace linked list with the linked stack. So just replace linked stack, linked stack, linked stack, linked stack, linked stack, linked stack. So also this will be linked stack underscore h, linked stack underscore h. So linked stack, so still we have few more linked list. So linked stack, so no more occurrence. So then you can see, so we can have here stack st get size, and here we can put stack, and then we can have here st. So we can test now. Save it first and then test. So we can have here linked stack test, and we can have one more function, void linked stack test, and we can include include linkstack.h header file. So we can linked stack and st, we can make one object and just see out st. That's so first three lines are output from the queue test, and this we can have 0 stack elements in the stack. So then you can dot push 30, you can push 30, 40, 50, 130, 310, and then you can again see out, and then you can have st dot pop, and just it will return. So returned node is deleted, and then see out again st. So you can see uh, 5 elements are pushed onto the stack, and one element is popped out. So you can try. Please make these implementation by yourself, and in the next step we will um, make the templates classes of all these classes. So far we have node class, linked stack, linked queue, and linked list. So then we will have some